Hey Chemsters, this is Mrs. Vanderlei bringing you more Chemster videos. We're still in Chapter 8. We're still talking about chemical predictions. We left off with the beginning of decomposition when my computer decided to not work, so I had to quit the last section, and this is where I'm going to pick up again. So decomposition, we'll start over again, is where one reactant makes two or maybe more products. This is where you just recognize you have one reactant, so that will help you. Binary compounds is where they break down into their individual elements. So as we recognize NaCl, if you add, say, electricity to it, you're going to break it down into its elements. So what are the two elements of sodium chloride? Well, one of them is sodium, but what do you know about the other one? It's chlorine. What is special about chlorine? If you said it's a diatomic, you are correct. So what do we need to do now is balance it. So one sodium, two chlorines. What do I need to do with the two chlorines? I need to balance it so that I have two chlorines on this side. And now what just happened? Well, my sodiums are messed up. Now they're fixed. Okay, so that wasn't too bad. So why don't you try rubidium oxide? So pause this and look at your periodic table, hopefully you still have that out again, and figure out the formula for rubidium oxide, predict your products, and then balance. Go for it. So pause this and do this on your own. Okay, welcome back. Hopefully you pause this and you figured out what rubidium oxide is. The charge of rubidium is +1. It's in the group 1 column. So when I write the right formula, you get Rb2O. You had to crisscross, correct? And then what? Well, I'm going to make my elements out of it. I get some rubidium. And what do you know about oxygen? Oh, that's right. It is a diatomic. So now we're trying to balance it. If we look at my rubidiums, I need two rubidiums. But wait a minute, before I mess this up, I have one oxygen here, two oxygens here. So I'm going to put a 2 here, and I'll put a 4 in front of rubidium. Carbonates we talked about earlier. In the prior section, we were just talking about decomposition. Reactions go to probably be more stable. And what very, very, very stable substance comes out of your carbonate? And that's going to be your carbon dioxide. So take out your CO2, and then what's left? Okay. Well, okay, I'll take out my CO2. And so count. I still have 2 sodiums and I have 1 oxygen. So if you count there, all right, and all my carbons are used up, so you got to use up all your carbons. So that is my other product. And note what happens. Okay, it's not a fluke. Look at the charges here. Sodium is a +1, oxygen is a -2. When you crisscross, you do get Na2O. It works out perfectly. And in this case, you do not need to balance it. It already is balanced. So that's fabulous there. So why don't you go ahead and do number 2 and pause this and do number 2 on your own. Take out the carbon dioxide. Okay, hopefully you hit the pause button and you finish this. So here is the next one. We have carbon dioxide is taken out, and once again, when you take away 1 carbon, 2 oxygens, what's left? You are left with 1 calcium and 1 oxygen. And as it turns out, like we showed before, calcium is a +2, oxygen's a -2. You don't need to crisscross. CaO is the correct formula for calcium oxide, and it is already balanced. Okay, so what's a tad different with this next one? You have, oops, hang on. You're going to notice that you will have to balance this one. So go ahead and pause this and see how you do. Well, hopefully you figured out, oh yeah, because iron has a charge of +3, carbonate has a charge of -2. You did have to crisscross. And you're still going to make the same things. You're going to have a carbon dioxide. Now just hang on a second. How many carbons are in my formula right here? If you count, I have 3 carbons, so I have 3 carbon dioxides. And that may help you predict your other product, because I still have 2 irons, and I've used up 6 oxygens here, and I have 9 oxygens here. I still have 3 oxygens left over, and here it is. Oops, come here. It's not coming up. Well, you end up with Fe2O3, and that is the correct formula. So if you get Fe2O3, okay, and now you balance it, it is perfectly balanced. And notice the charge of iron is +3. Oh, there it is. And oxygen's -2. So when you crisscross, you do get Fe2O3. So hopefully that worked out well for you. Let's go to the next page and see how we do. So let's pause this. So then if we're going to decompose chlorates, it's ClO3, and go back and think about that gummy bear video that I had on Google Classroom, and notice how much fun that would be if you had a 5-pound gummy bear. You are blowing it up, and what is the fuel for blowing it up? It was the potassium chlorate. That's where your oxygen came to blow it up. And so chlorates are very, very good sources for elemental oxygen, which then can be used for another reaction, as we saw. So chlorates are going to decompose, and you'll always make oxygen. So all oxygens are going to be used up to make O2. You'll have no oxygens left over. So what is going to be left over is the metal chloride. So when I do these, I always do the oxygens first. So let's go ahead and put oxygen here. Here we go. And what else is going to be left over is your sodium chloride. And go ahead and balance this. You're going to notice that you're going to have to put I think a 2 here, a 3 here, and a 2 here. And it all works out beautifully. As far as calcium chlorate goes, again, the charge of calcium is +2. The charge of chlorate is -1. So you might want to put that here. All chlorates are always -1. And so again, you're going to take away all your oxygens, okay, and what's left over is calcium chloride. What's the charge of calcium? What's the charge of chloride? So you will have to crisscross, and you will have to come up with the correct formula. So now what's left to do is balance. So go ahead and balance that. Well, if you put a 3 here, you're right, okay? And everything else is going to be balanced, okay? Now, as far as this next one goes, this nickel chlorate, Mrs. Van Looy did make a mistake when making her notes. I forgot. I want to make it a nickel 3 chlorate. Now, nickel can be nickel 2 or nickel 3. We've already done a +2 up here with calcium, so I want to do a different one. I want to show you what charge of a +3 will do for you here. So go ahead and try to do this whole problem on your own. So write down your formulas, write down your products, and then balance it. See how you do. So, again, nickel is a +3 charge. Chlorate has a -1 charge. I'm hoping you got this as your formula. What are you going to take away? You're going to take away some oxygens and the nickel chloride. Well, what's the charge of nickel? It is +3. Chlorine is -1. So we end up with NiCl3. And now we need to balance it. Well, look at your oxygens first. You have 9 oxygens right here. So you have 2 oxygens here. We need to put a 9 here and a 2 here to make the oxygens balanced. Now if you put a 2 here, you're going to be good. Okay? Our next type of reaction is combustion. You've already talked about this. You're going to have a hydrocarbon plus oxygen making carbon dioxide and water always. Okay, so you need those 4 things to be combustion. Okay, so I have not taught you your organic formulas. Those are your hydrocarbons. If you take my organic class next year, we'll certainly learn them. So rest assured, we will give you the formulas for your hydrocarbon. Okay, you're not expected to know what methane is. Take organic and you will. Okay, so notice the setup. Here's my methane. an oxygen making carbon dioxide and water. It's going to be very repetitious here. You're going to see it's the same format the whole time. Now, we said in class, is there a shortcut to determine if this is going to be a more complicated problem or not? And we did find a shortcut. Look at your hydrogens. So 4 divided by 2 is 2. Good. That's an even number. And so this should be a very straightforward problem. If you get an even number of hydrogens, if it's just a hydrocarbon, then it works out pretty easily. So I have 1 carbon, 1 carbon, 4 hydrogens. I need to put a 2 here to get 4 hydrogens. And now I have 2 plus 2. I have 4 oxygens, put a 2 here. So the next one is the combustion of ethane. I'll show you again the format and what's going to happen in this one. I have the ethane plus water or plus oxygen making carbon dioxide and water. So if I look at this, what's 6 divided by 2? Hopefully you know it's a 3, which is an odd number. If you want, go ahead and put a 2 out in front automatically because you're going to have to in the long run, and save yourself that aggravation and just put a 2 there. It'll work out. So put a 2 there. How many carbons do we end up with? 4. 6 times 2 is 12, so I need to put a 6 here. And here I have 8 oxygens and 6 oxygens to equal 14. What times 2 is 14, and that's 7. And this works out because notice all my coefficients, they're not all even. So if you have an odd here like we do, we know that we did the right thing by putting a 2 out front. If you do end up balancing any of these reactions and you get all even coefficients, then please reduce, because that's what you need to do. It needs to be in lowest terms. So what I would like you to do is set this problem up totally on your own. Okay, and you'll see it looks a lot like the 1 and 2. So go ahead, pause this, and see how you do. Hopefully you got that for propane. You did not have to multiply everything by 2 because 8 divided by 2 is 4, even number, so it's just a very straightforward problem. Go ahead and do octane. So pause this and see how you do. So I went ahead and took 18 divided by 2 is 9. Oh, that's an odd number, so I put a 2 out in front. So I have 16 carbons, 36 hydrogens, so 18 times 2 is 36. And then I added up all my oxygens, so I got 32 plus 18 is 50, so 25 times 2 is 50. So that worked out pretty nice. What about my next one? Well, I'm going to kind of talk you through this one because it's not a pure hydrocarbon. We have oxygens in there. It's an alcohol, so it has OH in it. So it's still the same process. You just got to remember you have an O on that product, or excuse me, that reactant as well. So I would start off, save oxygens to your end. So I have 2 carbons, 2 carbons. I have 6. Don't forget you have another hydrogen. So I have 6 hydrogens there. So I'll put a 3 here. And now how many oxygens do I have on number 5 here? I have 4 plus 3. I have 7 oxygens. When you go back and figure this out, don't forget you still have one of them here. So I need 6 oxygens from that term. So I'll put a 3 there, and life is good. Okay, and notice that my little helpful hint, I had 6 hydrogens. 6 divided by 2 is 3. Oh, did I have to put a 2 out in front? No, I didn't, because of that O in there. So we go ahead and pause this and do the combustion of isopropyl and see how you do. So go ahead and pause this. Well, hopefully you filled this up and, or wrote this down, I should say, but notice what happened in this one, okay? So if I were to do this problem like I've been telling you, there's 3 carbons here, I'll put a 3 here. There's a total of 8 hydrogens, I'll put a 4 here. So it looks like I have 10 oxygens to play with, right? Well, I have a problem here because right now I have an odd number of oxygens. I have 1, and the O2 will always give me an even number of oxygens. So I need to make an even number of oxygens. So I'm going to put a 2 here. Oh, Mrs. Vanderwall, now these are all going to be messed up. Well, yeah, you're right. So I'll do that instead. So now I don't have 10 oxygens. It looks like I have all 20 oxygens. 2 of them come from over here, so the remaining 18 comes from there. Okay, so that's combustion. We have one more section that I want to do as part of this Chemster video series, and that's going to be the single replacement. So let's go to the next page and see what happens. Hey Chemsters, this is Mrs. Vanderwall bringing you the third installment of the Chemical Predictions Flipped Classroom. And this is going to be single replacement. Now we need to do something before we continue here. You need to go to your Google Classroom, which is right here, and scroll down where it says Chemical Predictions. There it is. And you'll notice it says Activity Series and Solubility Table Updated. So I want you to click on that, and hopefully it comes up, and look at the second page of that. It is an activity series which is ranking these different, oh, mine's finally coming up, ranking these different elements as far as how active they are. And while mine is slowly coming up, go back in your memory banks and remember when we were in the periodic table section and we looked at how active, how reactive these different elements are. So we said that the group 1 metals are more reactive than the group 2 metals, which are more reactive than the transition metals, which are more reactive than the precious, which is gold, silver, and platinum. And oh, okay, mine came up. Let me scroll down to the next page. My goodness, this is taking a long time. And here we go. Well, I scrolled too far down. So roughly this. And what do you notice here? That the first 2 elements are on top. These are the most reactive metals. And I think actually lithium is higher on there now. And they're your group 1 metals. And then what do you notice that was underneath sodium? Calcium, magnesium. Hey, those are your group 2 metals. And then aluminum follows. Okay, it's pretty reactive. And now we're coming into the zinc, iron, tin, lead. Those are your transition metals. Hydrogen shows up. Remember, I've been telling you all section long that hydrogen kind of thinks it's a metal, all right? It has an identity crisis. It acts like a metal, and that's why acids work out as well. But look at what's at the bottom. Those are your precious metals. So when we ranked them in Chapter 5, the periodic table, it's the same idea as these activity series. Pretty clever, isn't it? What else do you notice over here? These are your activity series of your halogens and your halides. So your nonmetals. Didn't we say the same thing, that the group 17, which is your halogens, are more reactive than your group 16, which is more reactive than... Yes, and fluorine is the most reactive of all the halogens. Why is that? It wants to grab those electrons from anywhere it can, all right, to fulfill its octet. Okay, it is the most electronegative element. It's going to be the most reactive of all. So you will have a chart like this on your test. You don't need to memorize it, but I wanted to make sense of it so that, you know, it ties in with what we've already learned. Okay, so have this. Now maybe you can split your thing so you have this open all the time, you know, split screen or whatever you can do here, but you need to have this handy. You'll get a hard copy of this next time we meet. So, but for right now, you need to toggle between this and your note. So let me get back to my note.